these are the topics that we will be discussing today. All right, so firstly, for a very successful Apex Nastran interoperability, we need three things to be successful. Firstly, we need to support keywords. Now, if you just look at the quick reference guide, it's about 2,700 pages just on the content of Nastran. So that's no minor feat to get that done. And then we need to be able to support orphan meshes. And this is now the first release of Apex that can import a mesh and generate geometry for the mesh to simplify modifications, etc. And then lastly, it's obviously important that you are able to be post-process your Nastran results directly in Apex. And all of this can now be done. So over the past few releases, they've steadily increased the number of keywords in Nastran that is supported through Apex, specifically for importing and exporting. But there's been a major shift since the last release for Iberian Lynx to support much more of Nastran, so you will see a dramatic increase at this stage. What we now support extensively is ID management, which is critical for Nastran users, as well as custom coordinate system, the ability to generate discrete RVEs as opposed to the automated ones that we've come familiar with inside Apex. Kinematic joints, that is quite useful for other users as well, and then rods and bars. The whole focus of this is to support more modeling with Nastran or simulation with Nastran. Obviously, it allows you to remotely solve while you continue in Apex, even though the plan is for Apex to be able to solve with its own solver remotely as well. That's not yet possible, so you can use Nastran remotely while continuing in Apex, and it uses less tokens. The other advantage is that you benefit of all the capability inside Apex for your pre-processing, and you don't lose any of your models that you have maybe in your library. Right, so with respect to that, because we now need to support ID management, they've introduced the probe with which you can now interact with your model to see node elements as well, because we traditionally receive errors from Nastran by ID number, and then it's obviously important to be able to find those entities in Apex, so they've now made that possible as well. So you can interact with elements or search for elements by ID number. Then next, the coordinate systems. I'll demonstrate that briefly, how quick and easy that is to set up. And Apex has a unique ability that you don't need to create the center of arc points to position your coordinate systems. Any time you needed to add a boundary condition or a joint or something, you can locate these interactively, and these automated center of sphere or center of circle locations will pop up. And there are three different things to take note of, specifically with regards to the coordinate systems. If you select a location on a face, the z-axis will be aligned normal to the face at that location. Then if you select the center of surface location, the z-axis will automatically align with the axis, whereas if you select a curve, the local x-axis will be aligned tangentially with that curve at that location. So just take note of that. That is the smart alignment system, but of course you have the ability to manipulate that should you wish to as well. Furthermore, these coordinate systems can be moved around and reorientated just as any other body after you've placed them. So they try to keep everything the same as far as possible. Just a note on terminology, the default is the integrated coordinate system. That's purely just your base coordinate system, whereas external refers to the coordinate systems that you've created yourself. Right, so on the image over here, we are basically indicating that we're not at the tip of the mountain yet of what has to be done. Iberian Lynx has gone a long way, but we're not at the tip yet. So we're hoping to have closed the gap to the end of the mountain with the next release in Jaguar. And hopefully you'll see as the new releases has come along, we've come a long way, and the development is speeding up quite dramatically. So just good to know some limitations with regards to Iberian Lynx that you've probably read through all of this. I'm not going to spend too much time on this yet. For the hardcore analysts out there, you guys always wanted to create RBEs manually. You can now do this as well, as opposed to the automated ones that Apex has introduced initially. But this also opens up the ability to edit existing or automatically created RBEs and ties as well. So that's one of the other things that's new, and we'll demonstrate the creation of kinematic joints as well, which is quite helpful because you don't need to worry about the different coordinate systems and local coordinate systems and whether or not you've released the correct degrees of freedom. Everything is done automatically for you and visually in a way that you can very easily check that your model is set up correctly. And just in terms of how connectors work in Apex, and this is true for both the connectors as well as the joints, as you have two sides and you have an intermediate element. So the typical workflow when creating these joints through the user interface is first of all to select the region for the number one side. That creates the first RBE. Then you will select the second side or all the entities where the entity or the joint should be connected to, whether that being surfaces or edges or nodes or points. And then lastly, the element itself is created in the middle. And this is done all automatically. You basically just select side one entity, side two entities, and everything happens automatically. And there's a little image showing what actually is written to the typical Nastran deck, if you were interested in how this actually works behind the scenes. And then orphan mesh supports, leave no BDF behind. Right, so people, as I said, specifically in the aircraft industry, work a lot with legacy PDF models, and they now have the ability to import those meshes and continue working with them. So typically how this works is Apex can identify features on the geometry and then create geometry for you based on the inputs that you provide. Now, just a note of caution, the geometry that is created here is faceted geometry. It's not the same type of geometry that is currently used in the Apex environment. So you might experience a few limitations in terms of editing and manipulating that geometry. But what is already implemented here is already very, very helpful, as I will show you in a moment as well. Another thing that is quite useful is should the BDF that you import have loads and pressures and other boundary conditions applied, Apex will automatically treat those as separate regions and create section geometry for it. So you will automatically see if a patch was loaded with a pressure, Apex will create a section or a portion which basically becomes a separate surface. If there was a point load, a mesh seed point will be created in the geometry as well as any line features. So those points of application essentially becomes features in the geometry that you can use further. A further note, just on the technical side, you are also able to export the faceted created geometry. It exports a parasolid file alongside this XMM file. Which it will recognize automatically should you import the parasolid later. It will identify that it is facet geometry and automatically search for that file. So just be aware, should you export the faceted geometry, that there's actually two files that go together should you want to share it with someone else. All right, lastly, just a few notes on limitations with this geometry that was created on a mesh. As I said, with that, we're also not there yet. And with Jaguar, they will also not be at the tip of the iceberg yet, but we will get there. What is currently supported, though, is the ability to use the Boolean tool for splitting geometry. Now, this is a weird one, but it's typically one of those workarounds that somebody found by accident, I think. The split on plane using the split tool works as well as mesh seeds, point seeds, and remeshing and retaining properties and loads and boundary conditions through the import. So the basics is there, but what isn't there is essentially all the other tools that we've come accustomed to inside Apex, like transforming, which is strange, edge ties are not yet supported, highly curved faceted bodies will retain the coarseness of the initial mesh, etc. Now, these are things that will change over time with the next releases. Another thing I thought of mentioning was, I can't remember now. But okay, so don't think, well, yeah, something like edge drag and vertex drag isn't yet supported on the faceted geometry, but those are some of the limitations that are only for this release, and some of them will be lifted in releases to come. Right, so bottom line is the Iberian Lynx is just the start for this particular capability. There will be many things to come, but currently we can do a lot. We can remesh, we can add loads and boundary conditions, etc., and at least use some of the capabilities to cut into that geometry to create holes or whatever we need to. Right, then in terms of post-processing, we can now post-process the Nastran results inside Apex, but only HDF5, which is a new result format that has been added in the later releases of Nastran. It's a popular result format in the high-performance cluster environment. So that is now a new result format that is possible to generate through Nastran, and Apex can read in those results. So when you export a BDF for Nastran to be solved from Apex, it will automatically request the HDF5 results for you, and you'll be able to add that automatically back. All right, so for those of you who are new to Apex, traditionally Apex was developed to have its own embedded solver, but due to the legacy of the customer base, there were so many people who still use Nastran who have legacy models still in the Nastran format, and for them it's now possible to at least have all the capabilities and powerful functionality in Apex, but still solve the models with Nastran. One of the things why this may seem silly, but actually isn't, because Apex doesn't yet import or understand all the Nastran capabilities, it will retain those entries in the imported PDF file when it exports the BDF. So if there are any cards maybe that aren't that common, Apex will just ignore it, but keep it in the card so that when Nastran receives the exported BDF, that it will continue doing what it needs to be done. You'll only not be able to still post-process some of those elements probably, but Apex will be able to post-process all the traditional elements that we're all used to using. Right. You have the ability to do minor edits on the BDF before solving it in Nastran and post-processing it in Apex after you've exported the BDF. What we can't do is add nodes or elements or move nodes at this stage, so those should stay the same, but you may edit the BDF and add or remove or modify single point constraints, loads, modify thicknesses or other material properties, add inertia relief, or add additional load cases outside of Apex. But for the rest, so this is things that will change over time as well. And then just some more fine print for those people who do this. But I know there aren't that many of you, so I'm not going to go through all this detail, but if some of you are interested in the detail, you're more than welcome to ask me for these slides. All right, so how do we know I have Nastran results available or not? Firstly, you cannot import Nastran results if you didn't export the BDF from Apex. So that's one of the first limitations you should be aware of. And when you go to the studies and you right-click on a scenario, in this area, if it's ghosted, if the option is disabled, it means that we didn't export the BDF with Apex. If that option is available, it means that you did export the results of the BDF from Apex and that you can then import it from there. Right, another feature that is new to Apex, the X cross-section point sensor. This is a very useful tool for creating maybe shear bending moment diagrams or get the summary of loads inside a structure, or get the sum of forces at a specific location through any complex structure. So, and what is important to notice, you don't need to create this beforehand. You can actually create this in Apex after you've already analyzed the model, which means you can move it, reorientate it, and get a new value for it. So, right, I'll demonstrate this on the model in a moment as well, how we can interact with our results and look at nodal results or element results, capture it in a table and export it for use in a post-processor, and even generate graphs inside Apex using the 1D tool. Firstly, let's have a look, what do we have in this model? So there's a few studies, 2 of which have been solved. And the first study, I can see that I can't import Nastran results. This means the results that are available has been calculated by Apex. And if I go to the second one, I see that I do have the option to import Nastran results, which in this case means the results that are available actually came from Nastran. And regardless of which one I post-process, I'll actually see the same results in this case. So at this point, I'm just going to show you the new capability with the probe. What I'll do is I'll switch on the stress fringe plot, and whichever result you've chosen on the fringe plot, which incidentally is also shown in the model over here, there are various ways of manipulating the fringe. You can either select the results on top over here, or you can select various quantities over here as well. So just a side note, when you look at your stresses like this, and when we look at the probe, by default we have the option to highlight entity numbers, but we can switch over to look at actual stress results. And let me just change the rendering so that we see the element edges. So with the probe target set to the fringe values and labels, we can come in and pick nodes. Now, if you just hover over a node, the value will appear, but once you've clicked it, it will actually stay on the screen, and everything that you've selected will become visible in this little table over here, table which you can actually sort by value and interactively see as you move through the table where those elements are in the actual model, as you see the highlighting changes. And from here we can also export the CSV file should you wish. So that was the nodal results. In terms of element results, just a note on that. The moment we use the probe, we now can't select nodes, but we can select elements. Let me just switch the target back on. And now you can see various nodal values of the unaveraged nodal values. And this changes along with the fringe value that you've chosen. Okay, so, and again, we have the different results available in our grid. When you use the 1D tool, you can now select points, and then those values are added to the graph. And if you do it in multiple stages, these values will be added as separate graphs. So you can overlay data like this, maybe go all the way from the center, something like that. Now I'd like to show you how to import a BDF file and create geometry on it. So I'll just hide the solids for now, and I'm going to import a BDF file that has no assigned geometry to it. Now I must obviously just make sure that I import the right one. Looks like it's this guy over here. You have a preview option to see in a text format, table format, what is inside this BDF file. Errors and warnings. It says there's one unsupported keyword, so and there's an unsupported parameter value, things like that. You can also decide or make Apex decide should it create a single part or duplicate or multiple parts according to materials or properties, etc. Now in this case there's only one material and I would like it to only have one part. So I'll import it. And there's a message that the material ID has just been updated. Okay. All right, and here at the bottom I now see a mesh. But note that this mesh has nothing else. There's no geometry there. There's only a mesh itself. What we also do see, however, is a load that came through with the BDF file. It does have material properties and it does have a thickness. So if we render the thickness over here, we can see a visual thickness property. But if you wanted to create a connector now between these two parts, it would be a lot of work, and I'm quite lazy, so I wouldn't like to do this. So traditionally, how you would have to do this is select an edge on this side and then select individual nodes on the other mesh. Now that's very inconvenient, especially if you have a lot of these to do. So this is where the new capability to generate geometry on top of an orphan mesh is extremely useful. And we get this option now over here. And depending on your feature angles, you can just select your body. And in a click, I've now generated geometry for my part. Now the beauty of this is that I can now actually remesh or manipulate the mesh in various ways. What I've just realized is I didn't execute, so let me just redo that again. That is a preview, and then you have to you have the ability to merge faces, and I'll show that to you later. So I just need to press that button. Now the geometry is created. Okay, so the ability I now have is on the meshing side to remesh or even manipulate the mesh. So maybe what I'll do is just show this part on its own with its geometry. So now I can manipulate the seed mesh. Let me just get this guy. Has hidden my geometry. I just want to activate that again. I can come in and see that I have 15 elements over here, but I can now increase this to 24. So interactively, I can now manipulate the mesh, or I can simply just remesh the whole body with maybe 1 millimeter elements, etc. That gives me a lot of power, which means now I can create those connectors quite quickly. So let's just show everything again, and I can go to my connectors, quickly create a rigid connector. In this case, I'll use compliant links on both sides. So I'll just select the first edge, select the second edge, and my connector is created. Oh, sorry, I didn't read my own error message. Both ends are not within an assembly. It's quite important to read the status bar. What I've forgotten was that this part lies outside the main assembly. So I just need to move it inside the assembly. Otherwise, the joints won't work. So now it will work. Okay, there we go. Okay, now it's just a matter of doing that. All right, and that's in essence a very quick way to work with a mesh that you've imported from the side. All right, so we want to generate a new analysis to generate results for. So what I'll quickly do is I'll add a force, maybe on this new body of mine. And I just need to modify the magnitude of the value. So yeah. And do the same for this guy, but use this one in a different direction. Okay. Right, so now we have loads applied to this new structure, and what I'm going to do, add a representation. I don't need to do this, but I actually want to show you later on how representations work. And in a representation, we actually have the ability to exclude parts. So if I exclude this newly added part, I can do the analysis on the whole system as if that part never existed, or I can include it. So I just want to do that so that I have a reference for when I exclude it later on. And this I'll now put in the analysis scene. At least before we export it to Nastran, we still have Apex's new ability to check everything for us in the model. It warns us that there are some unmeshed geometry, and if you're not sure which those are, you can double click and it will show you that the solids are unmeshed, but those are fine because those are the solids we've used to create the mid surfaces. And it also shows us that there are some bad elements, and if I click over here, it highlights those for me as well. So I don't even need to go into the element quality feature to go and find these. But for this case, I'm happy with this. So I'm literally just going to run the analysis. I just want to run static. But instead of running it internally, for now, I'll just export this one to Nastran and run it manually to show you how this is done. The only other thing I want to do is add the element forces so that I can show you the results of connectors like the beams, and those are quite useful. So for now, I'm just going to export to Nastran. The important step over here is to make sure the Apex Nastran Interoperability checkmark is checked. Apart from that, it's just a matter of location, a unit system that you're using or want to use, and export and read any error messages that you may have. So on the Nastran side, all I now need to do is double click so Nastran can do its thing. Okay, that will run in about 20 seconds time. And while it's doing that, I want to show you the cross-section sensor tool that we have available. Now there's been already a few set up in this specific model that aren't shown here. There's the one and here's the other one. These were pre-set up, but to add new ones, a very simple procedure. Select the part or parts that you want the results to be averaged for, and pick a location and orientation. So as with any other tool inside Apex, just grab on these arrows. You can click R to rotate that section, and the sensor will now be created like that. So if I just show it again. So there's now a sensor over there. And it seems Nastran is finished in the background. So what I'll do now is import my Nastran results and use these new sensors. So over here we can see that there's no results available, but I can import my Nastran results. I just point to this newly created H5 file, and my results are available for post-processing. Okay, so there's the normal results, and what I now want to show you is a number of things with respect to the sensors. So if you look at your sensor, what you need to do is double click in this post model so that it becomes purple, and that then shows the results available at the bottom here and in which format the results are available. Now for the cross-section sensor, the results are only available in vector format or arrow format as you want. And what we can see now here is some of the arrows. Just need to change the visualization a bit so that we can see all of them. That's now just the one sensor's results being populated over here. There's the other sensor. If you want to show the values for them, there you can see in this case that would be the what is that? Probably the resultant value for these various sensors. Okay, so there's sensor 1. Plot the resultant value or any of the other components. Again, you can use your probe. Just switch to the vector option, so get results in your grid over here. All right, so there's new other things as well. One thing that is quite useful in the new release is with auto hex meshing. Once you've rendered the body to show that there's a problem and it can't hex mesh, you can now diagnose the problem. And I'll show you a nice example of that as well. So you can just right click on the body, diagnose meshability, and it will highlight the reasons for it not being able to hex mesh. Another good example, especially when cells turn yellow, it means they're hex meshable, but there's something that prevents them. And typically, as in this example, the mesh seeds of the adjacent cells are not the same, which means hex meshing is then not capable to create connected elements. So that's where this diagnostics helps quite a bit. Incremental surface meshing is a new concept, and that's very useful when you have washes in your model. And typically, when washes are too big and they get to the edge of the mesh or they get close to one another, that complicates matters quite a bit, and you can now prevent this by pre-meshing them and modifying each one at a time. I'll demonstrate that. It's quite a neat utility as well. Some enhancements with regards to edge styles for people that use them a lot. They can now be duplicated when you copy parts of the model, and they can interactively update as well as you edit models. So you can now edge drag your surfaces, and your edge styles will update automatically along with that. Previously, that was not possible. You can also suppress them and unsuppress them. So that's very, very powerful. Then they've now added the revolve, sweep, and extrude and lofting tools, and I'll demonstrate some of that as well. All right, and then quite important, we now also have the ability, apart from running scripts, to also customize the user interface to create little forms for your own script. So if you've written a script and you need to be able to pick entities off the screen to be used inside your script, that is now possible. And here's some examples of what people have done, like creating a flexible tube around a specific parameterized pre-design. And they've created their own little form to do that. Just a side note, for those of you who may not know, there's an ability a few releases back that in the modeler, there's a section view, which allows you to see all the section thicknesses and have them grouped. That is specifically useful if there's a section without a thickness and you can't find them. That could be quite difficult to find. Now you can easily identify them. So just be aware of this capability, because not many people are actually aware of that. Okay, so now I'm going to import a new solid part. 3. Right, so here I have a new bracket, and I would like to make this part of the analysis, and I'm quickly just going to show you a few of the new features specifically related to the hex mesh capability. So the first thing to do is to render according to hex meshability. So it's not hex meshable at this stage, but that can be changed quite quickly. I'm not going to spend too much time on this. This is also not a new capability, so you should be familiar with this if you're not new to Apex. So I want to split this body, and I can use sections or multiple faces. So for this one, I think I don't need to do much more than that. For that, sorry, I just want to cut that cell by itself. Sorry, that's exactly not what I wanted to do. I just wanted to split this guy like that, right? And then just split that guy like that, so that I don't have too many cells. Right, so now my body can be hex mesh. So that's quite simple. My team view is getting in my way. So now I have an hex mesh body, but let's say I wanted 3 elements through the thickness over here and not only 2. Now, of course, we can just simply add a C. But what you will see now happening is suddenly this box turns yellow. Now, if there wasn't a pre-mesh before, it would not have turned yellow. And just to demonstrate that, I'll delete this mesh. Let me just find it in the model browser. So I can delete the mesh and my body is green again. So if I were to mesh this now, I would have my 3 elements through the thickness, because that wasn't a problem. But because I had a mesh there, then suddenly it becomes an issue. So if I can't figure this out on my own, we now have the ability to right-click on this yellow body and diagnose the issue. And the meshability diagnostic tells me I should select an individual cell, not the full body. And now it tells me that there's an inconsistent number of layers. So what has happened here is exactly that. We have too many layers over there and not the same amount over there. So we can just do that instead, and now suddenly my body is meshable again. So if I now only mesh this body, I can mesh it again. Right, so that diagnostic tool helps quite a bit, specifically when you can't see what the reason is for the fact that it's not hex meshable in the first instance. But that will only occur when there's a incompatibility problem, like in this case. So in this case, it's just a matter of understanding the reason for it, and then we can just remesh the whole body or just mesh that section. Okay, so that was it for hex meshing. What we can do now is, okay, and that I should probably show you as well, which is quite useful, is the ability to just modify or model a portion of a model. Okay, so I just want to delete this load. Don't want this at this stage because I now have the new part. I'm going to show only these ones. Create a new little assembly and move these inside. Actually, what I should do is I should actually be moving this into that assembly instead. And move this guy into this little assembly over here. Okay, so you have all these ways to analyze your model. And what I wanted to show you now is creating joints, which is the other new feature inside Apex. So if we now go to the connector options, we have all our standard joints like revolute joints, cylindrical joints, prismatic joints, planar joints, or cylindrical joints. And for each one, there's a little icon that shows you how that works. So if I come in to create a joint for these two lugs, it's a simple process of selecting the first end, selecting the second end, and Apex will automatically put it on the inside in the middle. If I don't like that location, I can change it, but in this case, that's exactly what I want. Now, how do I make sure that that joint did in fact connect correctly? Now, remember, we sit actually with a much larger model like this, but I don't necessarily want to reanalyze the full model just to check that this single joint has been connected correctly. So what I can simply do is run a modal analysis just on this portion, and I'll just fix the one component so that I don't have too many degrees of freedom or rigid body modes. So I can connect, well, in fact, I'm not going to connect the other side. I'm just going to connect this one. And let's just run this portion of the model inside Apex. So I'm just going to place it in an analysis scene. Apex is going to warn me of a number of things. The first thing, there's a few elements that I know about them. There's no material assigned, so that's quite useful to remember that I didn't assign a material to this new body that I've created. And the other thing, there's no loads. So that would be an error for a static analysis, but I want to run a modal analysis. So that's no problem anymore. Okay, so now I'm going to run a modal analysis and see how my system behaves. And if that connection indeed behaves like a revolute joint and not something else. Let's just give it a moment to run. You can follow the progress at the bottom here. It won't take too long and it's done. So now I'll look at results. I think I did maybe missed something. Let's just have a look at the first mode. Seems like I may have picked the wrong joint, to be honest. So clearly something is amiss here. This is not enough connection we wanted. So what I'll do now is modify the joint. Sorry. Oh, and that is indeed the case. I did create a cylindrical joint. That definitely wasn't what I wanted. So my boundary conditions actually showed that to me. So the benefit we now have is we could debug this model without solving the big model. We purely looked at this section in isolation, and that means it results much quicker. So you don't waste time solving your large model. Second time should go a bit faster because the computational parts have been created. So let's see what the results are like now. So firstly, what you should note, Apex in the post-processor jumps to the first non-rigid body mode. So it starts with the lowest mode that isn't the rigid body mode, and that's why it displays mode 2 by default, whereas mode 1 is the free body mode. And here we can now see that our body rotation is indeed the way it should be in the first place. if we now go through the higher modes, we can check that the connection is indeed the way we expect it to behave. All right, and as you can see, you can at any stage zoom in here if there's more than one mode in close proximity of one another, etc. Right, so that's quite useful, quite neat, and now we know that that lock or that joint is done properly. All right, so now I want to show some other capability and add some more to this model by importing another mid-surfaced or mid-surfaced body. And what I just want to briefly show you with this body is the incremental meshing, new capability. So instead of jumping in and modeling the model as we normally would, normally Apex does try to add a washer, but in this case the mesh feature washer wasn't activated. And in fact there were some mesh settings defined for washers over here. If we go to the washer settings, in Apex you have this ability to set up different rules in the way washers should be handled, and you can even subdivide them and have different rules for different groupings. Right, but this new method actually makes this even simpler, giving us the ability to go into the incremental method. Now what this now does is it gives us the ability to highlight one mesh at a time and manipulate its properties. So as an individual mesh, we can now play with the various aspects of the mesh. And this is still just a preview. It hasn't impacted it yet onto the model. But once we remesh, it does in fact apply those things. Now, this becomes more evident when you have larger holes that comes closer to one another. So if you have holes like this, at some point, then the washer starts to interfere. Sorry. Okay. So if the holes are too close together, that affects the washers, and it becomes difficult to fix those in the traditional manner. So using this incremental method, it's quite useful because now, as I said, we can work on one washer at a time and see and manipulate these various aspects of it and see what is probably a better set of values to use for it before we actually apply it or maybe apply it for the rest of the model. But this is a way to individually deal with washers. And then, as I said, once you've applied that, those settings stay with the model. And as you've probably seen, even if you vertex edge drag these elements, those washer properties stay there, regardless of the size. So it keeps those settings linked to your geometry. All right, so that was okay. Then there's another few features that is quite important that I wanted to show you with respect to the thighs. And what I'll do is I'll actually make a copy of this body, maybe make a few copies of it, and actually create some web stiffness for it as well. So let's quickly create a web stiffener, or maybe one or two, for this body. To see if I've done it in the right space. It doesn't really matter whether you fix your problems where you do that, so I'll just reposition it to the proper location. And now there's ways of quickly creating a stiffener. You can either sketch on this plane or maybe create it in a proper location, something like that. So one method is to quickly edge drag maybe do something like this. That's probably the nice, quick and dirty way to create the stiffener. The other option would have been to create one inside the sketching environment on that plane. In any case, it's actually going to be quicker now to just use the same principle here. I actually want to show two things here. First of all, this is your typical stitched mesh. Now, I would like to show you the difference between a stitched mesh and a glue mesh, as well as a tied mesh. Now, for a glued mesh, we should actually keep the gaps in place over here. Just need to check the thickness property. I see I don't have a thickness property yet, so let's create the thickness for it. Assign it to everything there. Okay, so that gives us a 5mm thickness. If we mesh those, they will obviously be meshed as part of that body. I want to make two copies of it and show you the differences between stitched meshes. And remember, I'm still working in my large model, which is probably not always the best idea, but I'm brave. But okay, so now we have a stitched version. I want to create a glue version, and I want to create an unstitched version. Okay, so let's get to the stitched version first. Why do we have stitched versions? Well, that's the typical traditional way of dealing with bodies. The problem with stitched bodies is that we can only have a single part, or they can only be in a single part. We can't have multiple surfaces from various parts stitched. If you want to have them in different parts, we need to use either glue or edge ties. Okay, at least we have all the options. I think what I'll do here as well is to maybe just move some of these into separate parts. I don't need to, but I think it would be better just from an organization point of view to have these in different parts, maybe even different assemblies, or maybe add a few assemblies to the mix as well. So the stitched body I'll keep like that, and then I'll have one that is unstitched. So I'll just quickly unstitch these bodies. Now all the bodies that you select together will stay stitched, so to have everything unstitched you have to be a little bit creative. Okay, but now those are separate surfaces, and what I'll actually do is create a number of parts and place them in some of those parts. And as they move, you'll see their colors change. Okay, that is still a single surface, it wasn't unstitched properly. Put that in a separate one. Okay, we're running a little bit out of time, so what I could do is maybe just stitch some of them together to be a single part again. Because we have a bit of a mixture over there, and that I could then into this assembly as well. So I just want to make sure there's a single assembly that is still a separate part. So I think I'm going to delete that one and maybe just make a copy of this guy over here. So I can illustrate the the concept of glue as well. Right, so if my bodies are in separate parts, then I can't stitch them. So if you ever do an edge drag operation and it fails, just read the instruction. You will typically get an error message that just says the parts has to be in the same assembly to get them stitched. So stitching only works when the surfaces are in the same. If you for some reason now need to have them in separate parts, you can choose the option to use edge ties. Just see edges first. Or surfaces first, then the edges. Okay, now I have edge ties, which makes these bodies connected not through shared nodes, but through physical connectors. What is neat about this option is that I can still freely move them individually as if they are separate bodies. And that is very useful. So I pick that web or stiffener and move it somewhere else. And as you can see, the connectors stay there as well as the meshes have updated. In a stitched part, you don't have that ability. If you want to move the web in a stitched part, you have to unstitch it, move it, and restitch it. Whereas if it remains a separate part connected through either glue or edge ties, you can interactively move them around at will. Okay, so these are physically loose parts. Now that will obviously not work, but just to show that they are indeed separate entities. On the glue side, that's also quite useful. The only thing is for glue, I can glue them together as is. So I could say, let's glue all these bodies together. And it failed because some sections is a missing section definition. So I didn't assign a section somewhere. So these don't have thickness yet. They lost their thickness property for some reason. Let's just assign them. Okay, so now they have our thickness. So glue will work even if you don't keep the gaps. But to me, the power in having glue is the fact that you can actually retain the gap, which means you don't have overlapping stiffness in there. And what you should also note is the fact that the glue visualizes the footprint of the glue, which can be very nicely shown if I change the thickness of one of the sections. Let's create a thickness of 10 and assign it to an individual mesh over there. Maybe not thick enough. Let's make it 15. And now you can actually see the footprint your glue has due to the thicker property of that body. You can see that body's got quite a thickness and it has a proper footprint, and it visualizes the elements that are in contact or glue contact. And this is all also generative, as everything is in Apex. So you can move this anywhere and your glue happens along with it, something that you cannot do with a stitched mesh that easily, at least. All right, I actually wanted to show you the analyses of each of these. I don't want to spend too much time. I quickly want to jump over to the customization, which I think I'll rather just show you as well. But trust me, yeah, it's quite nice to see and actually compare the results. It's actually important for your own education as well to do a comparison between a solid mesh, a stitched mesh, and a glued mesh. And you will actually find that the results of the glued mesh is far closer to the solid mesh than the shell mesh. In fact, if you do a comparison between a tape mesh and a hex mesh and a glue mesh, those results differ in equal amounts, whereas your stitched mesh actually has way more different results than that because of the thickness and the fact that it doesn't take the footprint of the glue face into account. On the other hand, the edge ties and the stitched meshes produce the identical results. So mathematically, they are dealt with differently, but the structural results that you get from a tied mesh versus a stitched mesh are identical because, in fact, the tie is nothing other than a type of a RBE connector. I just see that I have some glue created here that I've accidentally overlaid on top of the tied entities, so that can be deleted. To do that properly, I need to just switch to glue, and I can see the rendering of the glue and just delete them. Okay, so we get a clearer image of the ties alone. All right, so lastly on the customization, something I didn't show you was that I normally start a new model. And let me save and close this model. I normally start a new model with material already created. And how I do that is with a script that runs in the background that runs automatically every time a new model is created. Now, those materials that runs in new models weren't existing in the model that you saw on the screen because it was created by someone else. But in this new model, it shows there that my script is run successfully and that I actually have materials. Now, how this is done, it's a very simple script, and I've set it up to run through the application setting option that says every time a new model or a default model is created, it should run my little script. There's another way now to deal with or run scripts. Sorry, I wanted to delete this. So I'm just going to delete my materials so that the ones that are automatically created aren't there anymore. And I'll show you the new custom way. And there's a little button that I've created. And all it does is it manually, well, not manually, it now creates those materials, but only once the materials, once I click the button. So the materials weren't there, now they are again. That's really, really simple. To show you how simple it is, all it is these few lines in this particular script. These few lines are common to all scripts, so that is just something you copy over from any example script, and these lines you can get through recording a macro. So you typically record a macro, create the material, stop the macro, and edit the file and see exactly what the code looks like. Now, to create more materials is as simple as copying and pasting. Now I can give them new names over here. So once I've saved that, and I can just delete these materials to show that it does work. Run my script again. And what you should see now is 4 materials being created. So it's literally as simple as that. And I don't know if you've noticed, somebody else was playing a bit. Who could this be? And it opens up an image of Elvis. So in the presentation, some of the fine print shows that it's Windows, it's being built on the Windows architecture, and there is all sorts of capabilities now available to customize and create your own little user interfaces. So these are just some examples that comes with your model of Apex to show you how to create various tools and forms if you want to interact or build your own models like that. Right, so I think in essence, with regards to the what's new part of the presentation, that is it.